This is an example of an application that we did in Chapter 7, and it's about breaking even. In this particular example, we have a toy company that invests $100,000 to produce a new toy, and each toy costs $2 to produce and is sold for $10. And the question is, how many toys must be produced so that the company breaks even? That is, it doesn't make money, but it doesn't lose money either. So we're going to set up a couple of equations to solve this problem. The first equation has to do with total cost. And the setup is that total cost is equal to the cost per unit times the number of units plus any initial cost that it has. The initial cost could be, for example, salary for workers or just rent for the particular facility where the toys are being produced. So in this case, we have C is equal to 2x, the cost is $2, and the units or the number of units is represented by x plus 100,000. The next equation will be that of total revenue. Revenue is the amount of money that the company will bring in. It doesn't include what happens. It doesn't include the cost, but it just includes. It's only the money that it brings in. And that equation is made by price per unit, and in this case we have $10, and then times the number of units. And once again, x represents the number of units, or toys in this case. So once we have our two equations, one equation for cost and one equation for R, we have a system of two equations here. Now, breaking even occurs when revenue is equal to cost. That is, when the company brings in exactly enough revenue to cover the cost. It's not going to make money, but it's not going to lose money. So at this point, R is equal to C. Revenue is equal to cost. So I'm going to go ahead and write both equations again. There's my cost equation, and I'm going to write the revenue equation again. But since we know that since we're finding breaking even, the point where the company breaks even, and we just said that R will equal a C, instead of writing R, I'm going to substitute C and write C is equal to 10x. Now, since C is equal to 10x, I can take that 10x and substitute it back into the C in the above equation, in which case I get a new equation. 10x is equal to 2x plus 100,000, and I can easily solve for x in this case, and I get that x is equal to 12,500. And in the context of this problem, that is saying that the company must sell about 12,500 toys just to break even. So that is the company is not going to make money, but it's not going to lose money either. Another question that I can ask in this particular problem with this particular company here is the following. I can ask how many toys the company must sell in order to make a particular profit. For example, $20,000 worth of profit. And for that we have an equation. Profit is equal to revenue minus cost. That is, after you pay the cost, whatever's left is the profit. So P is equal to R minus C. And the profit, we have $20,000 that we want, and that's going to be equal to the revenue equation, which is $10 times X, or that's the $10 what we're going to sell the toy for, times how many toys the company sells, and then minus the cost, and the cost once again is 2X plus 100,000. And I'll simply start by distributing the negative and then solving it. And in this case, I get that X is equal to 15,000. And now 15,000 what? That's the number of toys that the company must sell to make exactly $20,000 profit. And that is it.